Astronomers have discovered a rare temperature-sensitive molecule that is usually associated with stars in the atmosphere of an exoplanet for the first time. The thermometer molecule chromium hydride is abundant in a narrow range of temperatures between 1,700 degrees Fahrenheit to 3,140 degrees Fahrenheit or 926 to 1,730 degrees Celsius. It was discovered in the atmosphere of the hot Jupiter exoplanet WASP-17b, which orbits an F-type star located around 1,000 light-years from Earth. The discovery of such a metal hydride, a metal or metalloid bonded to hydrogen to form a new compound, in the atmosphere of an alien planet could allow scientists to gauge the temperatures of worlds outside the solar system in a new way. At hotter temperatures, you see just chromium alone, and at lower temperatures, it turns into other things. So there's only a specific temperature range where chromium hydride is seen in large abundances. In this video, we will take a look at this bizarre exoplanet. We will take a look at what chromium hydride is and how we were even able to find it in the first place. But before that, don't forget to give this video a thumbs up and subscribe to never miss another journey through space. Discovered in 2009, a team of researchers led by David Anderson of Keele University in Staffordshire, England, discovered the gas giant, which is about 1,000 light-years or 310 parsecs from Earth, by observing it transiting its host star, WASP-17. Such photometric observations also reveal the planet's size. The discovery was made with a telescope array at the South African Astronomical Observatory. Due to the involvement of the Wide-Angle Search for Planets Consortium of Universities, the exoplanet, as the 17th found to date by this group, was given its present name. WASP-17b is named DITSO. The name was selected in the Name ExoWorlds campaign by Costa Rica during the 100th anniversary of the International Astronomical Union. DITSO is the name that the god Sibo gave to the first Bribri people in Talamancan mythology. WASP-17b was already known to be a pretty extraordinary and extreme exoplanet before finding chromium hydride in its atmosphere. The hot Jupiter is located just 4.3 million miles or 6.9 million kilometers from its parent star, so close that it completes an orbit in just 3.4 Earth days. To compare this, the Earth is located 93 million miles or 150 million kilometers away from our Sun. This proximity to the host star, called WASP-17, causes extreme temperatures on the hot Jupiter of around 2,060 degrees Fahrenheit or 1,130 degrees Celsius. That temperature is just right to host chromium hydride molecules. At hotter temperatures, you see just chromium alone, and at lower temperatures, it turns into other things. The extreme temperature of WASP-17b has another consequence. It causes the atmosphere of the gas giant to stand out. What this means is that, despite having a mass less than half that of Jupiter, WASP-17b is more than 1.5 times wider than our solar system's largest planet. This standing out makes WASP-17b have a very low density of only 13% that of Jupiter despite being bigger, which is roughly 0.17 grams per cubic centimeter. This makes WASP-17b one of the lightest exoplanets ever discovered. The chromium hydride was spotted by a team of astronauts in the atmosphere of WASP-17b while using high-resolution spectroscopy. Elements and chemical compounds absorb light at specific wavelengths, leaving their characteristic fingerprints in the spectra of light coming from a star, which can be assessed with spectroscopy. In March 2022, a significant breakthrough arrived in the form of data collected by the GRACES instrument, also called Gemini Remote Access to CFHT Espadianes spectrograph, located at Hawaii's Mauna Kea Observatory. The CFHT part stands for Canada, France, Hawaii Telescope. This pivotal data was further fortified by incorporating previously gathered information from 2017. Although its initial purpose was unrelated to the search for metal hydrides, the dataset utilized for this study included older data points, bordering on the fringes of the collection. This unexpected inclusion unveiled a hidden treasure of insights. They compared the spectra of light coming from a star when its orbiting planets were at its side to spectra coming from the star when the planet transits or crosses its face. In this second case, the light from the star has to traverse through the atmosphere of the transiting planet, and thus, the team can spot the fingerprints that weren't present in the spectra of light collected from the star alone. This tells the team which of these elements and compounds exist in the planet's atmosphere. High spectral resolution means having very precise wavelength information. They are combined by using various statistical methods, using a template, an approximate idea of what the spectrum looks like and comparing it to the data, and matching it up. If it matches well, there's a signal. All of the different templates will be used and tested until one gives a signal, which in this case was the chromium hydride one. This discovery opens a new chapter of exploration. Researchers are now compelled to expand their search for metal hydrides within the atmospheres of other exoplanets. It's plausible that similar evidence has been captured in the past, waiting to be unveiled. Thank you for joining us on this cosmic journey today as we delved into the exoplanet, WASP-17b. If your curiosity was sparked, don't forget to show your support by giving this video a thumbs up, and if you're new here and hungry for more space exploration, consider subscribing to our channel and becoming a part of our passionate community. We'd love to hear your thoughts, questions, or even ideas in the comments below for our next adventure. Our cosmic voyage doesn't end here. Stay tuned for more captivating explorations into the universe's secrets. Until then, keep looking up, keep dreaming, and keep exploring. And thank you for watching Daily Space.